Infinite series look scary because you think you have to add forever, but you don't. So today we're going to start talking about the p-series test, which in my opinion is one of the fastest and easiest way to test for conversion. So let's get started. So what even is a p-series? Well, p-series are going to usually be in this kind of layout where it's the summation from 1 to infinity as 1 over n to the p. That's it. And there's exactly one rule. So if p is bigger than 1, the series converges, and if p is less than or equal to 1, the series diverges. That's it. That's the only rule. There's no limits, no integrals, nothing. Just if p is bigger than 1, the series converges, and if p is less than or equal to 1, the series diverges. So let's put that into practice. So first one, the summation as 1 to infinity over oh sorry I can't talk. The summation of 1 to infinity of 1 over n squared. Well, this is already in p series form like we said. So right here, p, this is p, the exponent is p, so p equals 2, and according to our rule, if p is bigger than 1, the series converges. So 2 is bigger than 1, right? So the series converges. The series converges, and that's it. That's the whole problem. There's nothing else you have to do. You don't have to take the integral. You don't have to take no limits. There's no suffering. You just look at the number and plug it in. All right, next question. All right, the similar question, but we're going to kind of incorporate some exponent rules here. So, the summation as n equals 1 to infinity of 1 over square root n. Well, square root n, using our exponent rules, we know that square root n is just n to the 1 half, right? So this would be 1 over n to the 1 half, right? And p is the exponent in the denominator, so 1 half. All right, 1 half is not bigger than 1. It is not bigger than 1, so it diverges. And boom, that's it. Same rule, you just needed a little bit of a rewrite. All right, next question. This one kind of does trip people up a little bit. It's where a lot of people panic, but don't. The constant 7 does not matter, right? The 7 up here. It does not matter. Constants never affect convergence. So just focus on the exponent. So the exponent here is 3 fourths. All right? So let's use our same rule. Is 3 fourths bigger than 1? No. No. So this diverges. That's it. No special tricks, nothing. All right. So a lot of people are kind of get tripped up, like, oh, what the hell? There's a 7 in there. Don't. It doesn't matter. All right. Because if you think about it, it's the same exact series. You're just multiplying everything by 7. So it's gonna converge. If it's gonna converge in the first place, it's gonna converge when you multiply by 7. All right. So this is another problem where a lot of people do get tripped up because the denominator is not just n. But here's the key idea: constants and shifts don't change the power of n. So for a large n, let's say 100 billion, 2n plus 5 behaves pretty much the same as n. At that high of a value, they pretty much behave the same. So it doesn't matter what's in the exponent, what's in the denominator. It's still a p-series. All right, so we can still treat it like a p-series. So the p is 2, so p equals 2. 2 is bigger than 1, so this converges. And boom. All right, so here's the next question. All right, when you see this, you guys might think, okay, there's no way this is a p-series. And yeah, this is a little bit tricky, but all we have to do is just simplify. So let's simplify this out. So it would be n squared plus 3n over n to the fifth. So let's break it up. So n squared over n to the fifth plus 3n over n to the fifth. This simplifies into n, oops, sorry, not n, 1 over n cubed plus 3 over n to the fourth. Now, there's two ways you can think about this. First, you can kind of look at the dominant term. You can kind of see this one will always be bigger, right? Because n to the fourth is going to be much bigger than n cubed. And as n to the fourth grows, this power pretty much this becomes 0. Or you can split it up, right? You can see the first term, this is going to converge, right? Because this p is 3, 3 is bigger than 1. And then you can look at the second term and say, oh, this one also converges because the p is bigger than 4. So we can just say, since p, especially in FRQs, they're going to want you to write everything out. Since p is bigger than 1, the series converges. And you have to write out what p is. Series converges, but I'm a little too lazy to do that. But make sure on the AP exam, you write out what p is. Alright? So that's all there is to P series. It's not hard. There's nothing special you have to do. There's nothing, no integration, no limits. You just look at the denominator and look at the power. And in this case, you had to simplify a little bit, but it wasn't too bad, right? It was just simple algebra. You just look at the denominator, look at the power of the denominator. If it's bigger than 1, it converges. If it's less than or equal to 1, it diverges. And that's it. So I feel like this is a very easy test to do. It's right up there with geometric series test, right? It's super, super easy. And it really does come in clutch sometimes. So I hope you guys learned how to do this. Pretty fast video, but it's a pretty simple topic. So yeah, if you guys enjoyed this video, I'd appreciate if you leave a like, subscribe. If you have any questions or any other videos you'd like me to make, as always, just put them in the comments. And thank you guys so much for watching, and I'll see you guys in the next video.